Have you ever been in a meeting or sitting across from someone at dinner and watched them yawn and felt the sensation arrive in your own body a second later whether you wanted it to or not? Your jaw drops. Your eyes water slightly. You try to suppress it, and the effort makes it worse. And the person who started it looks at you with mild recognition because they've just watched the same thing happen to someone else, and the chain continues around the room. You are not tired. You were not tired a moment ago, but now your body is insisting otherwise, triggered by something you saw, something you didn't consciously choose to imitate. It crossed the gap between two nervous systems without any physical contact. Yawning is one of the most studied and least understood behaviors in biology. It appears in fish. It appears in snakes, which have no diaphragm and no obvious respiratory reason to open their mouths that wide. It appears in human fetuses in the womb at 11 weeks of development, long before they have any air to breathe or social cues to respond to. It is ancient, reflexive, and universal across vertebrates in a way that strongly suggests it is doing something important. And yet the precise function of yawning in humans remains, after decades of research, genuinely contested. But here's the surprising truth. The explanation most people were taught, that yawning increases oxygen intake when the brain senses carbon dioxide building up in the blood, has been tested rigorously and found to be largely wrong. Breathing more oxygen does not reduce yawning. Breathing air with elevated carbon dioxide does not increase it. Whatever yawning is doing, it is not primarily a respiratory correction. And the contagious version, the one that travels across a room through eye contact or even through reading the word yawn on a page, turns out to be one of the more revealing windows into how the social brain actually works. Today, we're unpacking what yawning actually does, why the standard explanation has failed every scientific test it's been put through, and what the contagious version tells us about the circuits that connect us to other people. To understand the problem with the oxygen theory, you have to understand where it came from and why it seemed so plausible for so long. The idea that yawning corrects a respiratory imbalance dates to the 18th century and is appealing in its simplicity. You feel drowsy, your breathing slows, carbon dioxide builds in the bloodstream, the brain triggers a deep involuntary breath to compensate. The wide jaw opening seemed to confirm it. Surely that exaggerated gape was admitting a larger than normal volume of air. The theory was taught in schools and medical textbooks for generations on the basis of its plausibility rather than any direct evidence. In the 1980s, a psychologist named Robert Provine began systematically testing the assumption. He exposed volunteers to air with varying concentrations of oxygen and carbon dioxide and measured their yawning rates. Neither manipulation had any significant effect. Elevated carbon dioxide, which would accelerate yawning if the theory were correct, did not change the frequency at all. He then asked volunteers to do breathing exercises that maximized their oxygen intake before measuring their yawning, with similarly null results. The respiratory correction theory, which had been stated as fact in educational materials for 200 years, had never actually been tested. And when it was, it failed. What the evidence points toward instead is a thermoregulatory function. Yawning as a mechanism for cooling the brain. Think of it like opening a window in a warm room, not to change the air for the sake of breathing, but to change the temperature. The brain operates within a narrow thermal range, and even small elevations in brain temperature are associated with reduced cognitive performance. The yawn involves a prolonged stretch of the jaw that increases blood flow in the facial and cranial arteries, and the deep inhalation draws cooler air across the nasal passages and palate in close proximity to the vessels supplying the brain. Studies measuring brain temperature before and after yawns have found a modest but consistent cooling effect. Experiments manipulating ambient temperature found that yawning increases in warm environments and decreases when subjects hold cool packs against their foreheads, exactly the pattern a thermoregulatory theory would predict. Studies tracking yawning across the day found a concentration of yawns in the periods immediately before and after sleep, which are precisely the moments when brain temperature transitions most sharply. The theory remains contested and is probably not the complete picture. Yawning also appears to be associated with state transitions more broadly, the shift from sleep to wakefulness, from rest to alertness, from low to high arousal. The behavior may serve multiple overlapping functions that were never cleanly separable to begin with. But the respiratory correction theory, the one most people carry from school, can be set aside with reasonable confidence. So, if yawning in its basic form is a physiological regulation mechanism, why does seeing someone else yawn trigger the same response in your own body? The answer, as is often the case in history, comes down to neural architecture that evolution assembled for one purpose being recruited for another. Contagious yawning is distinct from spontaneous yawning in almost every measurable way. It appears later in development. Infants yawn spontaneously from before birth, but do not show contagious yawning reliably until around 4 years of age, which corresponds closely with the development of theory of mind, the cognitive capacity to model other people's mental states. It is suppressed in conditions that impair social cognition. Research has consistently found that individuals with higher scores on empathy measures are more susceptible to contagious yawning, while those with lower empathy scores, including populations with certain neurological and psychiatric conditions, show reduced or absent contagious yawning responses. One study found that even reading a passage describing yawning without any visual trigger was sufficient to induce yawning in a significant proportion of participants, suggesting the mechanism operates through mental simulation rather than direct sensory mirroring. The neural regions most implicated in contagious yawning overlap substantially with those involved in empathy and social mirroring. The capacity to internally represent another person's physical and emotional state. When you see someone yawn and feel the response arrive in your own body, you are not simply imitating a motor pattern. You are, in some functional sense, experiencing a shadow of their internal state, because your brain has simulated it. The yawn crosses the gap between nervous systems because your brain models theirs. What this means is that contagious yawning is not a quirk or a weakness of the social brain. It is one of its outputs, a byproduct of the same machinery that allows you to feel discomfort when you watch someone else injure themselves, or to follow the emotional logic of a story about people you have never met. The susceptibility is not incidental. It scales with the depth of the social connection. So the next time you watch a yawn travel around a room, take a moment before suppressing your own. That involuntary jaw drop is not a sign of tiredness, not a respiratory malfunction, and not an embarrassing loss of self-control. It is your brain completing a circuit with someone else's, briefly and wordlessly confirming that their internal state has registered in yours. The most contagious thing in any room is not a virus. It is attention.